rotates up and down on the lateral media by muscles. So it has its own motor muscles. Those muscles are supplied by oculomotor nerve, trochlear nerve, and abducent nerve. These three nerves go to the ball of the eye and supply or give motor innervation to these muscles. Oculomotor 3, trochlear 4, abducent 6 for eyeball movement. The fifth one, trigeminal, is for sensory innervation. Okay, let me rephrase it. Sensory impulse from the skin located on the face goes to the brain via trigeminal nerve. This nerve, cranial nerve number 5, sensory innervation from the face. Sensory, that means skin, goes to the brain, one or the other, via trigeminal nerve. This is mostly sensory nerve, but it has some portion which helps for motor innervation of muscles, which help us to masticate food, so muscle self-mastication. So simply, trigeminal is from skin located on the face. And the sixth one, as I told you, for abducent, for muscle of the eye. When you come to the facial nerve, cranial nerve number 7, you can see it is also related with the face. When you remove the face, you will see many small muscles, which are very thin. They are skeletal muscles. They need motor innervation. So motor innervation for muscles of the face is via facial nerve. But sensory innervation from skin of the face is via trigeminal nerve. Don't forget the difference. Then number 8, vestibulocochlear, related with the ear. Our ear is a sense organ which helps for hearing and balance. The semicircular canals help in balance. Cochlea is for hearing. And vestibulocochlear. Vestibule for balance, cochlear for hearing. Number 8. When you come to number 9, glossopharyngeal. Glossus refers to the tongue. Pharyngeal, pharynx. Pharynx. Guroro in amharic. So both of them, the tongue and the pharynx, have their own muscles. They are supplied by the glossopharyngeal nerve. When we come to number 10, vagus, is the longest cranial nerve. It supplies all these structures. First of all, it originates in the medulla, goes to the neck, thorax, abdomen. So many structures in the neck, thorax, and abdomen are supplied by vagus nerve. It's the longest cranial nerve. For example, the lungs, the heart, the stomach, small intestine, large intestine, including muscles which move the ear. All of them supplied by vagus. When we come to cranial nerve number 12, hypoglossal. Again, glossal, the tongue. There are structures below the tongue or inferior to the tongue. So, tongue muscles. So far, the tongue could be supplied by hypoglossal nerve or glossopharyngeal. Then the last one, not the last one, this is the 12th one. The 11th one, accessory nerve, it's for muscles in the neck, especially two muscles, trapezius and sternocleidomastoid. These two muscles. These are functions of cranial nerves. This is a revision of what we have seen so far. You can repeat it at home. Then we have spinal nerves, 31 pairs, C1 up to C8, cervical nerves, 12 thoracic nerves, T1 up to T12, 5 lumbar nerves, L1 up to L5, 5 sacral nerves, S1 up to S5, 1 coccygeal nerve. So the spinal nerves originate from the spinal cord in pairs. If you take just the first cervical nerve, the left side, the right side. The second one, the left side, the right side, and so on and so forth. That's one. Okay. Not only this, the spinal nerves, as we have seen yesterday, they have roots, dorsal root, ventral roots. The roots again join and form a spinal nerve. Spinal nerve. The spinal nerve later on divides into two, or bifurcates into two. Forms ventral ramus and dorsal ramus. After that, it goes to the periphery. Not only that, when spinal nerves go to the most peripheral part of the body, they join other nerves and form networks. I didn't say ganglia. Rather, the nerves form networks. We call these networks plexuses. For example, we have a plexus known as cervical plexus in the neck, brachial plexus in the armpit or in the axilla, lumbar plexus in the lumbar region, sacral plexus in the sacral region. Then there is a small coccygeal plexus. I will repeat it. The spinal nerves, the moment they leave the vertebral canal via intervertebral foramen, they divide into two, ventral ramus, dorsal ramus. Later on, they form networks. We call these networks plexuses. For example, cervical plexus is meant to supply the neck, structures in the neck. Brachial plexus meant to supply the upper limb. You don't have any somatic plexus in the thorax. Rather, we have ganglia of the autonomic nervous system. Then we have lumbar plexus in the lumbar region, sacral plexus in the sacral region. These two are meant to supply the lower limb and pelvis and perineum. Okay. So plexuses are network of nerves, not collection of nerve fibers. Rather, network of spinal nerves. Again, the spinal nerves originate in the from the spinal cord in the vertebral canal itself, but they leave the vertebral canal via intervertebral foramen. When they leave the vertebral canal through intervertebral foramen, immediately they divide into two, a shorter or a thinner dorsal ramus and a thicker ventral ramus. The ventral ramus supplies the largest part of the body, which is anterior. That means the upper limb, lower limb, the trunk are considered as ventral part. But back muscles are small, lesser in extent. That's why they have a shorter ramus. Don't forget this important arrangement. Inside the vertebral canal, we have dorsal root, ventral root. But then they form a spinal nerve. This nerve by itself bifurcates into ventral ramus and dorsal ramus. Each ramus contains sensory neurons as well as motor neurons. Just to see the plexuses one more time, cervical plexus is formed by this spinal nerve, C1 up to C5. And it's meant to supply structures in the neck. Brachial plexus is formed by the union of this brachial plexus. It has roots, trunks, cords, and so on and so forth. Just try to remember these numbers, nothing else. C5 up to T1, cervical spinal number 5, number 6, number 7, 8, number 8 as well as T1. Together they form brachial plexus, which is meant to supply muscles in the upper limb. We don't have any somatic plexus in the neck, the thorax, and you have this lumbar plexus, L1 up to L4. This lumbar plexus, it supplies muscles of the abdomen as well as muscles in the lower limb as well as muscles in the pelvis. Sacral plexus is formed by this one. This all spinal nerves. By the way, this one is the largest plexus, formed by L4, L5, S1, S2, S3, and S4. You see, many spinal nerves form this sacral plexus. That's why it's the largest. So the plexuses are special networks or arrangements meant to supply a given part of the body. So again, this is a revision of the plexuses one more time. Cervical plexus looks like this, brachial plexus, lumbar plexus, sacral plexus. In the thorax, you have ganglia, sympathetic ganglion, which is part of the autonomic nervous system, and that's what we are going to see next. The autonomic nervous system, just like the somatic motor nerves, that means cranial nerves and spinal nerves, it has also its own nerves, or we call them preganglionic and postganglionic neurons, anatomically, okay? And so they are very tiny and very thinner. We have neurons here, okay? Neurons. Physiologically, they have their own function, but anatomically, the parasympathetic portion has its own preganglionic neurons and postganglionic neurons. The sympathetic portion has its own preganglionic neurons and postganglionic neurons. So it's not imaginary. They have their own structural components. When you look at sympathetic portion, the preganglionic neurons, that's because we have ganglia in the thorax, in the thoracic region. We have preganglionic neurons and postganglionic neurons. As a definition, anatomically, what we call sympathetic division is part of the autonomic nervous system where the preganglionic neurons originate from the level of T1 up to L2. The other way around, the preganglionic neurons originate from the level of thoracic spinal nerve T1 up to lumbar spinal nerve L2. That's why we call it thoracolumbar outflow. You don't see them anywhere. It doesn't mean body parts located above or below this don't need sympathetic innervation. They do need, okay? To do that, the sympathetic portion has long nerves going even to the ball of the eye. But the nerves, whatever the case, originate here. Which nerves? Preganglionic neurons. Don't forget that. When you come to the parasympathetic portion, the preganglionic neurons are closely related with these cranial nerves or these sacral spinal nerves. I will repeat it. The preganglionic neurons are related with cranial nerve number 3. Cranial nerve number 3, oculomotor. Fascial cranial nerve number 7. Silence, please. Yes? Glossopharyngeal nerve, vagus. These 4 nerves, vagus, glossopharyngeal, fascial, and oculomotor, They contain the parasympathetic portion of the autonomic nervous system, preganglionic neurons. Or they must have these origins, sacral spinal nerves 2, S3, and S4. That's why the parasympathetic portion is called craniosacral outflow. Craniosacral outflow. I will repeat this basic concept one more time. When you say sympathetic division, we mean preganglionic neurons originate from the level of T1 up to L2. Which neurons? Preganglionic neurons. Well, that's why it's called thoracolumbar outflow. And parasympathetic innervation division means the preganglionic neurons are closely related with these cranial nerves, oculomotor, facial nerve, glossopharyngeal, and vagus. Or they can be related with the sacral spinal nerves S2, S3, S4. You see, parasympathetic portion, craniosacral outflow. It doesn't mean these are located in this region. For example, thorax, neck, abdomen, they don't need parasympathetic innervation. It doesn't. But to reach those viscera or organs, the parasympathetic portion has long nerves going towards those viscera. The same is true with the sympathetic portion. Sympathetic portion, or the preganglionic neurons originate here, but the postganglionic neurons go upward. Whatever the case, the autonomic nervous system controls body parts where we don't have any conscious control of the brain. Because we cannot control the viscera intentionally, our brain controls it indirectly. That's why we have the autonomic nervous system. And I will tell you again one general concept. If you look at glands, the parasympathetic portion helps them to secrete glands. Okay? But the sympathetic portion inhibits that secretion. So even though they work hand in hand, their function is opposite to each other. I will repeat it. If you look at glands, for example, salivary gland, and so on and so forth, the parasympathetic portion helps the glands to secrete, stimulates them to secrete. The sympathetic portion inhibits the secretion. You can see they are located in a given, close to a given viscera, but their function is opposite to each other. They work hand in hand, but their function is opposite. This is not always. There are some exceptions. In some area, the parasympathetic could be a motor nerve. The same is true, motor nerve. What I told you earlier is just to remember their function in a simple concept. So let's go back to the sympathetic portion one more time. You see, take this one as the sympathetic ganglion located in the abdominal and thoracic area. These are the preganglionic neurons, and these are postganglionic neurons. You see, if our eye needs sympathetic portion or innervation, the nerves come from the thoracic region. They go upward to the neck and to the head to reach the ball of the eye. But the nerves must originate here. So preganglionic neurons originate from T1 up to L2. If you take the small intestine, it is innervated by preganglionic neurons, postganglionic neurons. Let's look at the parasympathetic portion. The nerves, or the neurons, would be located in the brain. Then preganglionic neuron related with oculomotor nerve, facial, glossopharyngeal, and vagus. Then preganglionic neurons form synapses in a given ganglia. We don't have sympathetic long ganglion in the parasympathetic portion. Rather, we have ganglia. This is ciliary ganglion related with the eye, sphenopalatine ganglion, submandibular ganglion, maxillary ganglion, otic ganglion related with the ear. They are separated ganglia, not interrelated. Whatever the case, these four cranial nerves related with the parasympathetic portion, or they can originate at this level, so preganglionic neurons and postganglionic neurons. Suppose you need parasympathetic innervation for the large intestine. It comes from the head through vagus nerve. The vagus nerve gives parasympathetic innervation to the large intestine, small intestine, pancreas, the spleen, the liver, the stomach, lungs, heart. That's why I told you earlier it is the longest cranial nerve. It has also motor portions. But don't forget this concept. Even though sympathetic nerves originate here, it doesn't mean we don't need sympathetic innervation in the head, neck, and head. The neurons reach there. Not only that, when they reach the heart, for example, they form cardiac plexus. When they reach the esophagus, they form esophageal plexus. When they reach the abdomen, they form superior mesenteric ganglion, inferior mesenteric ganglion, and so on and so forth. So, like we have plexus in the somatic nervous system, cervical plexus, brachial plexus, lumbar, sacral plexus, we have also a plexus here. But the plexuses are smaller, one, very fine. The neurons are very fine. Sometimes you need a microscope to see them. But they supply a given area, for example, the heart, the lungs, the aorta receive parasympathetic innervation via cardiac plexus. I will show you in the next diagram. Or like this. The heart. Look, this is a sympathetic ganglion. Ganglionic neurons, postganglionic neurons. When they reach the viscera, they form plexus. Here you have cardiac plexus, esophageal plexus, mesenteric ganglion, and so on and so forth. Let's look at the next diagram. Okay. This one is better. I'll come back. You see, cardiac plexus, which is meant to supply the lung, the heart. Esophageal plexus, superior mesenteric ganglion, inferior mesenteric ganglion, and so on and so forth. They also form plexus, but the difference is that the plexuses are very fine, very small, complex. Sometimes you need a microscope. This is it. There is also another concept. Yesterday I told you the spinal nerves contain sensory neuron, motor neuron. In addition to that, they also contain preganglionic neurons of the autonomic nervous system. This is ventral root, dorsal ganglion. They join and form a spinal nerve. This portion contains gray ramus, white ramus, which contains preganglionic and postganglionic neurons of the autonomic nervous system. And you can see this is a sympathetic ganglion. These ganglia are interconnected with each other, unlike the parasympathetic portion. Unlike the sympathetic portion, they are interconnected. For example, suppose the preganglionic neurons originate here in the spinal cord. They go peripherally like this, enter this ganglion, they form synapses. They may live toward the viscera, or they may go upward, or they may go downward. This is arrangement. So don't forget, we have gray ramus and white ramus. Especially we call them gray ramus communicantus and white ramus communicantus. But a spinal nerve, when it bifurcates into two, it forms gray dorsal ramus and ventral ramus. Let's look at a more detailed diagram of what I told you earlier. This is a spinal cord at the level of T1 up to T2, ventral horn. So cell bodies of preganglionic neurons. They live like this. Enter a given ganglion. They form synapses. They may go upward or they may go downward. When I say go downward, it is the post-ganglionic neurons. The preganglionic neurons end up here. When they end, they form a synapse. Let's look at this diagram. Again, preganglionic neuron, synapse. Some of them go upward, some of them downward. These two rami, gray and white, are meant for the autonomic nervous system. One more time, the sympathetic ganglion looks like this. So these are preganglionic neurons, shorter. Then the post-ganglionic neurons become long. They go to the plexuses. For example, let's look at cardiac plexus. It is formed by sympathetic portion and parasympathetic portion. It's meant to supply the lungs and the heart. This is the same thing we have seen so far. Let's go to the cardiovascular system. You see, this is what we have seen so far. If you want to know the function of each plexus, for example, ciliary ganglion is for eye. Okay, you see, these are glands which all these contain one or the other glands. Here you have lacrimal gland, salivary glands, some glands in the thorax, some glands in the abdomen, the liver. Okay, they need parasympathetic innervation. One or the other, it helps them to function normally. To inhibit those functions, in opposite part of the autonomic nervous system, we have sympathetic. Okay. You see, for example, in a gland, the sympathetic portion inhibits flow of saliva, but the parasympathetic portion stimulates flow of saliva. I don't expect you to remember all this. Just remember that parasympathetic portion is usually for secretion by glands. To inhibit the action of or the function of a given viscera, we have the sympathetic portion. Their function is opposite, even though they work hand in hand. Don't worry, we have about 90 minutes. I'll finish by 12 o'clock, okay? So this is በአማርኛ. Don't worry, I have much time. Can you see the PowerPoint now? Yes? ይታያል። እሺ፣ እኔ ግን ማረፍ አለብኝ። እሺ፣ 10 ደቂቃ ሀብቱ ምክንያቱም ለፈለፍኩ ሜዳ ላይ ለፍልፌ ነበር። እዛ ላይ ደግሞ ሻይ ልጠጣ 10 ደቂቃ ብቻ። እሺ፣ አልቆይም፣ ይበቃኛል። ሰዓት ታይም እስከ 6 ጨርሳለሁ። ኦኬ